Continuing our discussion on ADA, we talked about ramp. Typically, ramps have, as I mentioned, 1 to 12 slope for ADA as well as other pedestrians if they want to use the ramp. And you have the straight shot ramps, like, for example, you have a ramp that goes straight, and I'm showing them like three-dimensional, to a landing, and then that landing returns into a space in which there is an entry to the building or so. So this is a straight shot, you come up. The other one is the switchback, which means you basically will start, let's say here, just the way this one is. It's the first one. You come up to a landing. That landing will extend out, and you go up for another distance of whatever that length is required to satisfy the requirement. And then at that point you come into a landing, and that landing will allow you to, where this is that landing will lead you back to a entry to the building. 1 to 12. And anytime you have a landing, you need to have a clear 5 feet in front of the ramp for the wheelchair to turn around. What is known as the dimension is a circle with the diameter of 5 feet. This is the form of, or rather I would call it the main form of measurement for clearances for ADA. Excuse me. There are handrails that has to be used on ramps, and the handrails are typically 34 inches to 36 inch from the surface of the ramp to the top. So that's 34 to 36 inch when there is a slope, and then when it comes to a landing, the landing height of the guardrail has to be at 42 inches. So this is the handrail at the slope area. Excuse me. And then this is the landing. So the height will increase to 42 inches. And the code requires you to block this. So when we are looking at a detail of this, of these pipes, or however that is, it might be a sheet of glass, so it's fully covered, but it's still transparent. The center line of the pipe, is 4 inches. And same goes for the handrail. Now, for the steps or the stairs, and this is a general rule not only for ADA, but for all publicly used buildings. If you have a stair which I think I might have mentioned that before. Here's your steps. This area is thread, identified with T. This area is riser, identified as R on the drawings. This projection in here, which you see it also here, this is minimum 1 inch, and that is called the toe space. Now, the maximum, again, you're dealing with a publicly used building. The maximum riser height is 7 inches. Minimum thread is 11 for this. Now, when we talk about the thread, let me make this correction. The dimension of the thread is from this edge of the toe space to here. So this is that dimension of 11 inch. When you add the toe space, it becomes 11 plus 1, which is 12 inches. So in terms of the dimension, that is the thread dimension. Now, how do you calculate number of risers for buildings? Let's say you have a floor here, and you have another floor here, and you need to create a stair that goes from one floor down to another. So you come down here, landing, come down here into this floor. So how would you be able to calculate number of risers for a building? The way it gets calculated, let's say you have a top of the floor dimension to top of the floor dimension of 14 feet. So that is floor to floor height. So floor to floor height, I make it 14 feet. So the number of risers are calculated by height, floor to floor, multiplied by 12 and divided by 7. That's 12 is for conversion to inches, and this 7 is maximum riser height allowed. Now, since we are dealing with the stair, you got to remember, not everyone in a disability is on wheelchairs. Some people might have difficulty walking because of some problems that might be at their legs, or some people might have slower movement because of the same reason. Some people might have other issues relevant to their movement, so still they can use the stair, but you still have to have an appropriate height so these people can comfortably move on the stair. They are not necessarily on wheelchair. So, number of risers, height floor to floor per feet. So let's say it's 14 feet, multiplied by 12 divided by 7. So that means that it would be 14 multiplied by 12 divided by 7. And when you do the calculation, it gives you 24 risers. That means you need to have 24 of these risers, each at 7 inch for going 14 feet floor to floor. Now in the next lecture I'm just going to talk about shortly about how you will be dealing with, in case instead of 14 feet here we have a more very round number, what happens if this number becomes fractional? Let's say you have floor to floor height of 13 feet. And what do you do with that one? So I'll follow up on that on the next lecture, which is coming up shortly.